Welcome, sixth grader. Today we do scientific notation. Many times this is one we have a lot of extra questions on, but if you remember multiplying by 100 or 10 or 1,000, a number with a 1 in front followed by all zeros, and those tricks, or dividing by that, this becomes rather easy. If you don't, well, it can be tricky, but once you understand it, I think you'll be good. So, 724 times 10 to the second. We need to think of that as 724. Well, what's times 10 to the second? 10 to the second is 100, because 10 times 10, that makes 100. Now, what I'm going to tell you to do, think 724 times 100. Where is the decimal in that? All the way at the end. You must always start at the decimal. Always at the decimal. Always at the decimal. This is the big problem because in other grades, you only work with whole numbers, so it's just, add zeros on the end. No, you must always start at the decimal. So there are 1, 2 zeros. So since I'm multiplying, I add 1, 2 loops. My decimal is in a new spot here. If I don't have anything there, I fill it in with zeros. My number just went from 724 to 72,400. That is the shortcut way of doing that multiplication. We move the decimal, the number of zeros. Okay? Let's see if we're right. 72,400. Now with this one, if I see, there's 1 0 since it's just times 10, I know the decimal's right here. I fill that in. When you're multiplying, you move right. It's going to be 8,370 for our answer. With 100, there are 2 zeros. But hold it. The decimal is not here. That's not right. I've got to make sure I start at the decimal. I move it 1 place. 2 places. Fill in the empty place with a 0. Notice the 9 filled in one of my places. My number is 63,290, and we're ready to move on. Remember, Mrs. Letcher only works with whole numbers, so she says just add zeros at the end. I'm making a slight change to that because of decimals. You start at the decimal, and you move it the number of zeros, and that number you have, there's 2 here because we know that. All right. So she taught you very well, but I got to add one more thing because we're getting a little more complex. Learn to write large numbers in scientific notation. So, scientific notation. All right, so find each product. They want you to multiply. I need you to know where is the decimal in 5,892. Hopefully all of you know it's at the end of the 2. Now times 1,000, that means I'm going to take 5,892, if I can write on the board, with a decimal that's right here. It says times 1,000. We start at the decimal and move it 1, 2, 3 spots. We fill in those 3 spots. We have our new number. Our new decimal, our new decimal is out here. So we get, comma there, 5,829,000 for our answer. And a lot of you may be saying, Mr. Palm, well, it is just Mrs. Letcher's rule, which she has taught you very well, of moving or adding zeros to the end. But really what we did is we moved that decimal 3 spots because we had 3 zeros in that number. This is a fast method to do it. We really need to understand what that means. 3 zeros, we move it 3 spots. They show up wonderfully there. Then write the placeholder zeros, 5,829,000. Here, it is important we write the number as is, 47.75. It's important we're very careful with our loops as well. There are 4 zeros, so I start at the decimal, because the decimal's right here. I start at the decimal. 1, 2, 3, 4. I have a new place for my decimal. I fill in the placeholders. This time, instead of adding 4 zeros, I only added 2 because our decimal was in the middle of the number. So it's 477,500. 477,500. All right. There are 4 zeros. We start at the decimal. Yay, they do that too. Then we get our new number, 477,500. With 901, we must know where the decimal is at. The decimal's right here. When it's at the end, yes, you could use Mrs. Letcher's rule, and she does that so well teaching it to you. But here I see 3 zeros, a 1, a 2, a 3. New decimal spot, fill this in with zeros. Each empty dip gets a spot, it gets a 0, okay? That's important to notice. Some of you will get sloppy and it will not end well. So 901,000. Okay. There they moved the decimal 3 spots because of 3 zeros in that 1,000. And we get 901,000. With this one, don't be tricked. Decimal's right there. We always key on that decimal because it tells us where to start. Now I see 4 zeros, so I know I go 1 spot. Notice I go between the numbers. 2 spots between the numbers. 3 spots, and an empty loop. I only fill the empty loop with a 0. I put my new decimal there. Oh, now I can write my number. 1, 5, 4, 2, 5, and a 0. I add my comma to know what number it is. 154,250. Notice there was only one placeholder, even though we moved the number 4 spots, because we always start at the decimal. Let's see how they should. All right. 15.425. Hey, there are 4 places, so they moved it 4 places, and we got our brand new answer. All right. So that was expanding numbers, multiplying them by 10 or 100 or 1,000 or 10,000, or even bigger, 1 million, 100 million, all those. Why do we use this? Scientific notation is a shorthand method that can be used to write large numbers. We're dealing with space and science. They're talking about trillions of miles. They will like to write those in scientific notation. Otherwise, they're writing a number that is 10 and 15 and sometimes 20 digits long. Scientific notation has a 2-number system that will allow it to be much shorter. So, they do something like this. 4.123 times 10 to the 5th. And that, if you know what the shorthand is, makes the number very easily understood. The first part is a number that is greater than 1. So there's a whole number, 1, 2, 3, 4, 5, 6, 7, 8, 9, on the left side of the decimal. Then all the important numbers that are non-zero on the right side of the decimal. Then over here, the second part is a power of 10. So 10 to the 5th, that's 10 with 5 zeros. 1, 2, 3, 4, 5. Oh, that's like saying 4.123 times 100,000. Okay? That's what the shorthand means. So write 6 million in scientific notation. All right. So we always want to get the decimal to this location with one whole number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the whole numbers. Left of the decimal. So first you got to think, where is the decimal in 6 million? Oh, it's right there. Then this is where, boys and girls, you must be careful. You count the places to get to the spot you want to be. Remember, we want to be where that blue arrow is? 1 spot, 2 spots. Notice I'm going between the zeros. 3 spots, 4 spots, 5 spots, 6 spots. So I get a new number that is 6.0. Okay? Now, how many spots were there? 1, 2, 3, 4. Notice I'm counting the bottom of the loop. 5, 6. Bottom of the loop. Oh, times 10. Since there were 6 spots, it's 6 loops. And the reason for that is, if I take 1 million times 6, don't I get 6 million? Oh. Okay. Let's walk you through it as they say it. Okay. Move the decimal points 6 places left. I counted them. These, they do not do a very good job of marking them. They should be between the zeros. Okay. 6 spots to get the decimal where we want it. Okay. So 6, and I put 6.0 because that's actually technically the correct way to write it. And since we moved it 6 spots, we have an exponent of 6. 10 to the 6th. And when we did 10 to the 6th, 1 million, that's what 10 to the 6th is, times 6, we get back to 6 million. Okay. Here, we need to start where the decimal is. Oh, the decimal's right here. We need to get to that spot where there's one whole number left of it. A 1, a 2, a 3, 4, 5, 6. Oh, it just happens to be 6 again. Now, I write 4 point, and I have to write all of these numbers I just put a line above because they're not zeros. 3, 2, 5 times 10. How do I get the number that is my exponent? Oh yeah, 1 loop, 2 loops, 3 loops, 4 loops, 5 loops, 6. I moved it 6 spots. 10 to the 6th. 10 to the 6th is 1 million. If I take 1 million, which is 10 to the 6th, times 4.235, I go back to this. With millions, scientific notation is a little bit helpful. When you're talking numbers that are 15 and 20 numbers long, that really helps. Let's watch their approach. All right, there's the number. Move the decimal 6 left, so we know we get here. Then we have our new number, 4.235 times 10 to the 6th, because we moved it 6 spots. You can write a large number written in scientific notation in standard form, looking at the power of 10 and moving the decimal point that number of places to the right. Here's what that means. Oh my gracious. I'm going to write this number out on the bottom because this will be a little bit easier to work with. 6.2174. The next important thing to look at is that exponent. That tells us how many places we're going to move something. I could say 10 to the 3rd. Oh, that's 1,000. Now I know 3 zeros, I move it 3 spots. Hold it. Wasn't this a 3? So you could just look at the exponent. I start at the decimal, and I move it 3 spots. 1, 2, 3. I have a new number. I have 6,217.4. I just changed it from scientific notation to standard form, how you would normally write the number. All I did was I started at the decimal, which is right here. I looked here, 3 spots, that means move it. A 1, a 2, a 3. I'm multiplying, so I know my number should get bigger. Once I did that, oh, there is my answer. Let's see how they show it. All right. Watch these examples many times. Watch them when you're doing this type of problem. It will be helpful. 6.2174. All right, move the decimal 3 places because there was the 3 in the exponent. All right, 6,217.4. All right, so how many places are we going to move it? Oh, 3. Start at the decimal. A 1, a 2, a 3. New decimal spot there. Write it out on your own. 3,219. You can put the comma in there. Make sure I know it's a comma. 7, 5. Oh, we get our answer. The exponent. That tells us how many spots we're moving to the right. Because 10 to the third is 1,000. 10 to the third is 1,000. I'm sorry, my computer's not cooperating. 3 zeros. That's how we know 3 spots is the place we want to move. We start at the decimal and move 3 to the right. Because when you multiply, you're going to get a bigger number. All right. Very good, very good. They did the same thing, got the same number. Now, we're going to practice writing big numbers in scientific notation. All right? So here's another practice example. First, I gotta know where the decimal's at. It's right here. Yep. Where do I want it to be? One spot where there's one number spot left of that. Oh, I want it to be right here. Because then 1, 2, 3, 4, 5, 6, 7, 8, 9 will be left of the decimal. So let's see. Count our loops. 1, go between the numbers. 2, go between the number. 3, 4, 5, 6, 7. 7 means 10 to the 7th. Yes, it does. All right. Now my new decimal spot is right here. I write a 9. I write the decimal. All these are zeros. I don't need to worry about them. I do need to worry about the 3. 9.3 times 10 to the 7th. Because there were 7 loops. Okay. Let's go ahead and look at their work. Nine point 3 times 10 to the 7th. I need to know where the decimal's at. Right there. I need to move it to where it's with one spot left of it. 1, 2, 3, 4, 5. 5 spots. That means 10 to the 5th. 1.325. I only write these because they're non-zeros. Okay? There is one other example I really like to show you, and we will probably do that. 1.325 times 10 to the 5th. We practiced it again. Oh, give me just a second. My board decided to stop using its write feature. All right, I am still talking here. We'll work on an example here in just a second once I can get my board working. We're literally one or two problems from being to the end. All right, there it's back. Whew, good deal. All right, so we go here. Next. All right, hey, we got the same answer as them. All right, good deal. That's everything we need. I want to show you one more example. They don't give you an example like that, so we're going to go back here and we'll do the example. Oh, feathers. So we're going to look at the number 1,206,000 with all zeros. Now, to write that in scientific notation, I know the decimal's here. I move it 1, a 2, a 3, 4, 5, 6. Because I want to be with one place value left of it. Now, I moved it 6, so that's times 10 to the 6th power. 1.206. I don't include these zeros because they don't hold a value. This one is important because it kind of helps to make sure that 206, that's a lot different than 26 if I would take it out of there. So it is important if there's zeros between numbers, we have to write them. But if the zeros are at the end, we do not write them. So zeros between numbers, we do write. Zeros at the end, we don't have to write. Thank you, 6th grade. I know this was a long one. Try it out.